The National Electrical Code, or NEC, does not have a specific requirement that limits how close a lighting outlet can be to a service drop. However, it is generally recommended to keep them at least 3 feet apart for safety and for ease of maintenance. In addition to the NEC, local codes and ordinances might have extra rules about how close lighting outlets and service drops can be to each other. It is always a good idea to check with the local authority having jurisdiction, or OJ, to make sure you are following all the right regulations. Even if the code doesn't specifically say you need to keep a certain distance, it is a good idea to keep a reasonable separation between lighting outlets and service drops. Firstly, safety. The service drop carries high voltage electricity. If a light fixture is placed too close, there is a potential for electrical arc flash or other hazards. Secondly, maintenance. If you have enough space around the service drop, it will be easier to get to it for inspection, maintenance, or repairs. Thirdly, aesthetics. Placing a light fixture right next to a service drop can make things look messy. So, while the NEC doesn't specifically say you can't put lighting outlets and service drops close together, it's generally recommended to keep them at least 3 feet apart. And it is important to check with the local HJ to see if there are any other rules you need to follow. Maintaining a safe distance between a lighting outlet and a service drop involves several considerations beyond the minimum 3-foot recommendation. It's not just about avoiding immediate hazards, but also ensuring long-term safety, maintainability, and compliance. Let's delve deeper into the factors that contribute to making an informed decision about the placement of these electrical components. Firstly, voltage levels. Service drops typically carry higher voltage than standard lighting circuits. For instance, a service drop might carry 240 volts or even higher in residential settings, while commercial buildings can see service voltages of 480 volts or more. Lighting circuits, on the other hand, usually operate at 120 volts or 277 volts. The higher the voltage, the greater the risk of arcing and electrical shock, thus necessitating a larger separation. Secondly, environmental conditions. The location of the service drop and lighting outlet can expose them to different environmental conditions. For example, coastal areas with high salt content in the air can accelerate corrosion of electrical components. Similarly, areas prone to flooding or heavy rainfall can increase the risk of water intrusion into electrical boxes and conduits. In such cases, additional protective measures like using weatherproof enclosures and corrosion-resistant materials become crucial. Thirdly, accessibility and workspace. The NEC mandates specific clearances and working spaces around electrical equipment to allow for safe operation and maintenance. For example, NEC Section 110.26 outlines the requirements for working space about electrical equipment operating at 600 volts, nominal or less. These clearances ensure that electricians have enough room to safely access and work on the equipment without risk of accidental contact with energized parts. When placing a lighting outlet near a service drop, it's important to consider these workspace requirements to avoid obstructing access to either component. Fourthly, future expansion and modifications. Electrical systems often undergo modifications and expansions over time. When placing a lighting outlet, it's wise to anticipate future needs and leave room for additional wiring, conduit, or equipment. Crowding a service drop with a lighting outlet can make future modifications more difficult and potentially compromise safety. Fifthly, grounding and bonding. Proper grounding and bonding are essential for electrical safety. The grounding system provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices like circuit breakers to trip and energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. When installing a lighting outlet near a service drop, it's crucial to ensure that both components are properly grounded and bonded in accordance with NEC requirements. Sixthly, physical protection. Service drops and lighting outlets should be protected from physical damage. Service drops are often located overhead, making them vulnerable to damage from trees, vehicles, or weather events. Lighting outlets, especially those mounted on the exterior of a building, can be exposed to impact from objects or vandalism. Using rigid conduit, guards, or other protective measures can help prevent damage and maintain the integrity of the electrical system. Seventhly, coordination with other utilities. Electrical service drops often share space with other utilities like telephone, cable television, and gas lines. When placing a lighting outlet, it's important to coordinate with these other utilities to avoid conflicts and maintain safe clearances. For example, the NEC specifies minimum clearances between electrical service drops and communication cables to prevent electrical interference and ensure safety. Eighthly, local amendments and interpretations. As mentioned earlier, local jurisdictions may adopt amendments to the NEC or have their own interpretations of the code. These local requirements can vary significantly from the national code and can impact the placement of lighting outlets and service drops. It's essential to consult with the local AHJ to understand and comply with all applicable regulations. Ninthly, documentation and labeling. Accurate documentation and labeling are crucial for maintaining a safe and reliable electrical system. The electrical panels should be clearly labeled to identify the circuits and equipment they serve. Wiring diagrams and as-built drawings should be kept on file to provide a record of the electrical installation. When installing a lighting outlet near a service drop, it's important to update the documentation and labeling to reflect the changes. Tenthly, professional consultation. Given the complexity of electrical installations, it's always a good idea to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to assess the specific site conditions, identify potential hazards, and ensure that the installation complies with all applicable codes and standards. They can also provide valuable insights and recommendations to optimize the safety, performance, and longevity of the electrical system. In summary, while the NEC provides a baseline for electrical safety, there are many other factors to consider when placing a lighting outlet near a service drop. By considering voltage levels, environmental conditions, accessibility, future expansion, grounding, physical protection, utility coordination, local amendments, documentation, and professional consultation, you can ensure safe, reliable, and code-compliant installation. Let's consider some practical examples to illustrate these points. Imagine a scenario where a homeowner wants to install a motion sensor light on the side of their house, near the service drop. The homeowner might be tempted to place the light as close as possible to the service drop to maximize its coverage area. However, this could create several problems. If the light is too close to the service drop, it could obstruct access for utility workers who need to maintain or repair the service drop. It could also increase the risk of electrical shock if the light fixture is accidentally damaged or if water enters the electrical box. To avoid these problems, the homeowner should follow the recommended 3-foot separation and consult with a qualified electrician to ensure that the installation complies with all applicable codes and standards. In another scenario, consider a commercial building owner who wants to install a new security light on the exterior of their building. The building has a 480-volt service drop, and the owner wants to place the light as close as possible to the service drop to minimize wiring costs. However, this could create even more significant hazards. The higher voltage of the service drop increases the risk of arc flash and electrical shock. The commercial setting also means that there is likely to be more foot traffic and vehicle traffic around the service drop, increasing the risk of physical damage. To address these concerns, the building owner should consult with an electrical engineer to design a safe and code-compliant installation. The engineer might recommend using a larger separation distance, installing physical barriers to protect the service drop and lighting outlet, and using explosion-proof lighting fixtures to minimize the risk of fire or explosion. The NEC also addresses specific requirements for outdoor lighting and service entrances that are relevant to this discussion. For example, NEC Section 225 covers outside branch circuits and feeders, including requirements for the installation of outdoor lighting fixtures. NEC Section 230 covers service entrances, including requirements for the location and protection of service conductors. These sections provide additional guidance on how to safely and effectively install lighting outlets near service drops. Furthermore, it's important to understand the different types of service drops and their associated clearances. There are two main types of service drops: overhead service drops and underground service laterals. Overhead service drops are typically installed on poles or buildings and are subject to specific clearance requirements to ensure safety. For example, the NEC specifies minimum clearances for overhead service drops above roadways, sidewalks, and buildings. Underground service laterals, on the other hand, are buried underground and are subject to different requirements for burial depth and protection. When placing a lighting outlet near a service drop, it's important to consider the type of service drop and its associated clearance requirements. The NEC also provides guidance on the selection and installation of lighting fixtures for different environments. For example, NEC Section 410 covers the requirements for luminaires, lamp holders, and lamps. This section includes requirements for the type of fixture, its location, and its protection from the environment. When selecting a lighting fixture for installation near a service drop, it's important to choose a fixture that is suitable for the environment and that meets all applicable NEC requirements. In addition to the NEC, other industry standards and best practices can provide valuable guidance on the placement of lighting outlets near service drops. For example, the Illuminating Engineering Society, or WISE, publishes recommended practices for lighting design and installation. These practices can help ensure that the lighting system is safe, efficient, and effective. The National Electrical Manufacturers Association, or NEMA, also publishes standards for electrical equipment, including lighting fixtures and service entrance equipment. These standards can help ensure that the equipment is reliable and performs as expected. By following these industry standards and best practices, you can further enhance the safety and performance of the electrical system. Finally, it's important to remember that electrical codes and standards are constantly evolving. The NEC is revised every 3 years to reflect changes in technology, industry practices, and safety concerns. Local jurisdictions may also adopt amendments to the NEC or develop their own codes and standards. To stay up to date on the latest requirements, it's important to regularly review the NEC and consult with the local AHA. In conclusion, while the NEC does not specifically prohibit the placement of lighting outlets near service drops, it's generally recommended to maintain a minimum separation of 3 feet for safety and maintenance purposes. However, this is just a starting point. A variety of factors, including voltage levels, environmental conditions, accessibility, future expansion, grounding, physical protection, utility coordination, local amendments, documentation, and professional consultation, should be considered to ensure a safe, reliable, and code-compliant installation. By following these guidelines and consulting with qualified professionals, you can minimize the risk of electrical hazards and create a lighting system that meets your needs and exceeds your expectations. Remember, electrical safety is paramount. Taking the time to carefully plan and execute the installation of lighting outlets near service drops can save lives and prevent costly damage. Investing in professional expertise and adhering to industry best practices is always a wise decision when dealing with electricity.